Mm-hmm. Characteristic range initialize. Right, yeah, so if initialize wants to stop in the middle, right? That was the idea. If initialize itself wants to stop in the middle, then we can just yeah, enter it from the top, I think. And this one is also at the top. But of course we need to know if that is the case. So I think that we need to test return value of initialize. Let's use the opposite of that. Oops. Let's say it returns true if it is finished. Otherwise it isn't finished, and we just break out of here, causing us to return to the same state when we start again. I was going to add a yield, but it's not really necessary, because I think that the only way it is allowed to return false is when I do a wait. So initialize is going to call wait and then return false, and then I just break. That's the way to exit here. Same thing here. There's not fill, break. Right. But I also need a run state. Yeah, actually I want to make the derived class also a task, subtask. I forgot how to do that. I did it before though. Let's look at the different task that I have that is split up in two. If I could remember, let's just keep this for now. I think that async task is one such thing. Well, I had more of them. Synchronous, well, one of these. Let's look at async task. And that's hardly doing anything. This thing doesn't even have a state of its own. That's not useful. What about this one? It only has a single state, but okay. Better one state or nothing. Right. Also not useful. Here's a trick. If the type ID synchronous task is the type ID of this, then we start with synchronous task start. Otherwise we start with state end, which is then actually the first state of the derived class. Okay, I have no idea. Do I not have examples of this? Do I have to figure it out myself? Let me think. Right, of course. Multiplex implementation is a virtual function. So this is not the entry point anymore. We have to make it so by starting to implement a derived class. The class that implements initialize, I'm afraid. And then I want to use initialize. I think you have to do away with initialize completely. Is Phil currently a virtual function? And it seems that it is, yes. So instead of having fill and initialize, I guess I just have to hijack the virtual function multiplex implementation. It is again rather complex. So we have here two virtual functions, but we're not going to call them anymore. Instead, we are treating this now as a task. I mean, it is a task. It's now derived from AI stateful task, which means that multiplex implementation is called. It is also a virtual function. But then, of course, the multiplex implementation of the most derived class is being called. comment this out for now as well. So what classes do I have that are derived from characteristic? That one. These are comments. So just my two test applications. And I'm using this one currently mostly. So begin with this one. So this base class here is derived from CharacteristicRange, which is now derived from AI stateful task. So that is a task, so this is a task, so this has become a task. And I want to interrupt initialize. Actually, I forgot why I wanted to do that. Well, I guess it doesn't matter. Okay, I'm afraid I don't have a recipe really for turning a derived class into a task. I should have that. Please let me have documentation on it. I think I do. So the only thing that I have is stateful task. Prerequisites. Initialization. Definitely missing documentation here. We do have using direct base type. I can look for this. Then I might find another example. Now there's a few examples. That is it's not really true. I need one that is not having AI schedule task as direct base class. Maybe that one is an example. Let's have a look. That's not too bad. So immediate submit is a task. Yeah, also very minimal, but it has two states. Even this one is not derived from AI stateful task. It's derived from async task. Immediate submit request, continued, pointer, to states. It defines a state end in the usual way, and then we have the overrides of virtual functions here for tasks. Looks pretty much like a task. Let's have a quick look at the multiplex implementation anyways of this immediate submit. Okay, pretty minimal, just 2 states, but it's doing something. Set state m continue state. Wait, submit finished. Okay, so at the moment this thing is constructed, so we pass it a continue state, which I think is then a state of the derived class. So this is literally just the beginning, and then when we get the submit finished signal, then we continue in the derived class. For example, in copy data to GPU. Now here's the constructor of the immediate submit. Are we immediately done after that? That is the continued. But okay, let's just start implementing this. See how far we get. I need copy this, so let's look in this top. Okay, I'm gonna have it protected. Let's put this in front of the constructor. If we have a constructor, oh, this is the constructor. Constructors protected. Why the hell would that be protected? Oh, this is also a base class. Even this is a base class. Yeah, the direct base class is this one. Substitute, copy data to GPU. Becomes holy moly. No music. Obviously, we do not have a write or a flush. Begin simple. It's just a start and a done. And then, yeah, initialize must be transformed into something, but for now, let's just add these things. These are protected. I need a protected virtual destructor. I don't think we have a destructor. No, I have a destructor. We are protected. Okay, just add it here then. I don't have a Windows LCXX. Yeah, I don't have that. So I do everything inside this class. That's why it is a test. I'm not even sure I need an initialize implementation, I have to admit. Too large than 9J. That wasn't even good. Now I'll get 19. Nope. Yeah, we have two states. Let's find them back. This one and done. I don't think I have this one, nor this one at the moment. Hello, Ghost. Those are the two states. But now what? Okay, so now we enter here instead of in the multiplex implementation of the base class, because this is a virtual function, so it's just going to call the virtual function of the most derived class. But we want to begin with the multiplex implementation of the base class. And there is a trick. The trick is that the initial run state is set to a state of the base class. So what happens is we come here with a run state that is not ours. Which is also definitely why we should never implement this one. That should set the first starting state. I do, however, think that we explicitly need to set it then in the base class, because otherwise I have no idea what it really will do. Hell, let's just test it. I'm gonna run it in the debugger and see what happens. Multiplex. So what I want to do is that the first time we get here, I want to know what the run state is. And then let's just stop. Yeah, I did comment out initialize. And so this has to be temporarily commented out. You know, you should not even get here at the moment, so call nothing. Field all source commented out. Yeah, and then this does not exist either. Talking about breaking your own code. Still initialized things left. Oh, that one. Well, in this case, let's keep it. Just remove the override. Just freaking compile. Okay, so now I run it. Core dumped, and it did print something, I hope, before the core dump. Oh, what? I don't see any output. Oh, right. Yeah, that's another one. We're trying to print this base class state. So also this is also an overridden virtual function. So it's the only one that's being called basically, and we are being called here for the states of the base class. So the same thing applies as here. If it's not ours, we have to call the state string implementation of the base class. Okay, I think I just go over all the state string implementations that I already have and then find one that implements that. If any. As you can see, there's one. Yeah. So if it's not ours, then we will not return, and we get here, and then we have to call that. Oh, this is for the condition, not for the state string. But I guess it's very, very much the same thing. Probably something like this. Let me look anyway for the state string implementation. Finally we have one, and indeed it's exactly the same thing, but with state string implementation over in state. Yeah, and that was a copy that I did to GPU. It was kind of the only one that I could find really that derives from task. So instead we have to do here that never reached. Not true. I think it's beautiful. So most derived class, virtual function, this is being called, and if it is not ours, then it must be one of the base class. Crash actually happened elsewhere, not in my assert false, although this also is an assert false. They never reached. Now it prints it as a 7. That's not useful. Well, the reason that it prints it as a 7 is because I did not implement my other function. Namely the condition. We have a character const pointer condition string implementation. No, it's not true. That's not true at all. Well, we're gonna need this, but of course this is nothing to do with I don't even have a condition yet. So it looks a lot like this, and anyway, might as well already add it. Let's put it in front of the state string implementation, just as the other class does. I don't have anything yet. Not sure if this compiles. A switch without any case at all. Don't know. Yeah, it's kind of strange that I did not print the state, although I did here. Characteristic range initialize, I think that is the state. But then why is it not printing it here? Because it's just an int. I'm an idiot. You have to explicitly call state string implementation. And to prove to myself that that is the case, I'm going to find this line and then use the state string implementation. I should have done state string implementation. Yep, so now it prints it. So the first entry is indeed the base class. The characteristic range initialize is the first state of the base class. And then what happens is that we cannot find it here. And therefore we will come here. And then we can just call the base direct base class. I'm not sure if the direct base class is the right thing here. That's a good one. Hopefully it works. Because the actual direct base class does not implement a multiplex implementation. So I have class A that implements it, and then derived from A B that does not implement it, and derived from B we have a C, that is this one, and then from C multiplex implementation we call B multiplex implementation. Is that going to call C multiplex implementation again, or is it going to call A multiplex implementation? Or is it going to say that it doesn't exist? I would say it's very dubious, and I cannot tell you what will happen. I have no clue. Let's try out. So either this works-ish, or not even sure how I can tell that it works then. Or we get into an infinite loop. But the infinite loop we can recognize. So what happens? Chord dump. I would say that it worked. Trying to find the same point as we were before. This one, right? Yeah. No, that is the pipeline factory initialized. Characteristic range initialize. This is set state running. Yeah, that's the one. Yeah, it worked. I think this signal is part of the base class. So it did call CharacteristicRange multiplex implementation. That's the one that it called. If I could type it correctly. Multiplex. Which then calls this function. Which then called that signal. The signal was 4, right? So characterized initialize is 4. Yep, it is. So confirmed, we have a working multiplex implementation. So now we call the base class, and this was the initial thing. And it should start with calling initialize. Yeah, and that is it. Then not what we wanted. I don't really want to start here at all then, do we? Or do we? I want to replace this with the multiplex implementation of the base class. And then when it returns, we want to call this. So this is not initialized, it's more like initialized with a D at the end. And the initial state should be probably, yeah, just the start state of the most derived class. They don't want to start here. So we're going to call this initialized. While the other one is just going to be filled after the fact. So filled is not correct. This is filled. Okay, or something. That's initialized. I don't know. That's fuzzy programming. It does work on two ends or in multiple places, and it grows slowly towards each other. So nothing works, and you are editing multiple places at the same time. That's basically it. But at some point it should start working. So one of the problems was now that the initial state is the first state of this base class. But that's the after the fact. This state should be executed after the initialize returned, this function. So we should not start here, we should start with the first state of the derived class. Which means that I do need and yeah, let's move this down. Still not using it, but initialize implementation. We do set state. So this is the most derived class. So this is the initialize function that is being called prior to actually running the task. And then a set state inside that function sets the initial state. So we do this, then now the first state is going to be this. And now we're actually going to do something. I can print here the out. Notice we get here, and then we crash because we just leave without doing anything. But that's okay, at least you can see that we got there. It's not compiling. Characteristic. Oh, fill. Yeah, I didn't update. The last one is now filled. I am using my mouse, by the way, to copy long strings. Okay, this does not exist anymore. Oh, where are we now? The CharacteristicRange. No, yeah, it doesn't make any sense, but I'll just put filter, otherwise it doesn't compile. I was actually looking for this part here. Initialize and filled. And Kobe Wills, thank you for the compliment. Crash. Yep, we get here. That worked. So let me see if we can follow it. What more or less happened here. This is in initialize implementation, where we set the beginning state, and then we go from initialize to multiplex, and we simply run the state, which prints we get here. Okay, now let's call initialize x from here with the pipeline value. See, that takes integer 0 or 1. So I'm just adding the framework for this derived class, for the being a task of the derived class, and then we still call the same function, you know. In the end, I'm going to copy the body of this function into this multiplex, and then we can split it up with new case statements. And that then will allow us to leave the function at an arbitrary point and re-enter it at the case label, somewhere in the middle. That's the idea. But for now, we just call this function. Because that's the first thing we want to do. Let me think. I need to add this pipeline. Are these my variables, the private variables? Well, now it is a member of a variable of the class. I don't have to pass it anymore here. I don't have to call it X anymore. But here's a differentiator code for each pipeline. And that's it, I think. Oh, not entirely. I also passed it to this function here. Add shader resources too. And that changes the requirements that it put on which descriptor set to use. But that's only a hint. In the end, the engine is going to say, fuck you. It's much better to use the same descriptor set. But that's the whole test, that it could do that. So I'm giving it different hints, and then it's going to say, well, let's not do that. Let me see. I have I was using different types even for the characteristic. I guess I could do away with that, or I could just keep that and set the pipeline value here in the constructor. Though that feels kind of silly. Let me think. I'm gonna delete it, I think, and then see what happens. So let's not use base anymore. Uniform buffers test pipeline characteristic base. Let's just remove the base part. We don't have this anymore, and we're going to set this new M pipeline value directly. Now it's using this constructor, but now I need to set an integer. So we're going to add an explicit constructor for this thing by itself, which takes a pipeline variable. And I happen to know that we need to pass more. Let's say I'll just copy that from the characteristic. Even more, owning window. So well, that's the base class. We have it here. The base class takes these two. And the pipeline is initialized from this one now. Okay, let's try to compile it and let all hell break loose in terms of compile errors. So deleted the 0. These are now the same type, but I just pass to the constructor. Still errors. A member function virtual create graphics pipelines, no matching function for call to add characteristic int window pointer bool. Candidate. I think I went too fast. So passing it not to the constructor, but passing it to add characteristic. Yeah, I can hardly add a int pipeline here. We cannot. Plus this is not the one. This is the one. The owning window must be up front, and then the arguments are passed to new characteristic owning window comma arguments. Well, this is our type, but this is the this code here is the Vulkan engine. And that just insists of having the owning window up front and then the extra arguments after that. So we get to make a small change here. Forgot where that was. There it is. Add characteristic. Yeah, could have known. Could have known that. I'm wondering what happens. Yeah, right. I changed the base class into the final class. And if you remember well, that did have a protected constructor. It's protected within this context, protected here. So now this indeed has to be not protected anymore. And we still get the same error or what? Or is it different? It is different. Initialization of vulkan pipeline factory handle add characteristic. Invalid conversion from const task synchronous window pointer to int. Well, that's Matas. You can be scared of these errors because you don't understand them. But then look at the changes that I make. The changes that I make to fix it are simple. So I just swap two arguments in the last function that I forgot to swap them in. So it's not hard. It's just getting used to the errors. And of course, I've been reading this kind of errors daily for decades. So I can reasonably fast scan through it and skip most characters and just go straight for the most important part. But if you start with C++, you start with simpler programs. And then you get simpler errors in the beginning. And then you just advance once you have, when you understand those. But, yeah. I guess there's no way around wrestling with them for a couple of years at least. So that might be scary. Anyway, this is now compiling, and then I forgot what I was doing, of course. Get div again. Yeah, right. I got rid of two derived classes, so the base is now the real class, which has a pipeline variable instead of a different type. And I turned it into a task. That happens here. And then the implementations of the base class task and the derived task are still complete nonsense. So those are the ones that I have to fix now. But I think the framework for the task itself is there. So we can concentrate on the task as a task. Just look at it now as a task and ignore the framework that is needed around it. And well, this is the task, this function here. So we begin with this thing. It calls initialize, and then it returns, which doesn't do anything. It just returns to the task engine, which is going to conclude that this task is not finished because you didn't say that it was finished. And it's going to say, I'll keep giving you CPU. So you do break here, break out of the switch. Oh, that's not what we want. Holy moly. I have to do a return, otherwise we call that one. I have the feeling that would be a little bit smarter here to use a default. You really only want to do that when these cases do not exist. Or I could use a return here, but I'm used to break. Anyway, so yeah, break out of the switch, which means we leave the function, and then it will immediately call the function again. So that would be an infinite loop calling initialize infinitely number of times. We definitely do not want that. What we want is that we continue with something in the base class. And there is no reason not to know what that state is in this derived class. It's a derived class, so it knows everything about the base class. Now these states are defined as an enum in the class, and that means that the derived class can also access the states directly of the base class. So I just set the state to the base class and then I break out of it. But what then happens is that we are called again immediately from the top, and then we take the default route here. So that seems kind of like inefficient to leave this function and then enter it at the top again and then do this. It would work, but maybe I should use returns, you know. So I'm turning this back. Now let's set the state to that also won't work because the run state didn't change. Nah. What would be a good way to do this? You could skip this call and just pass that directly to the multiplex implementation. But it is also slightly dirty, because then we are going to execute a state without setting the state to be that state. So I feel like whenever I'm executing a state, I really have to call set state. But yeah, that doesn't change run state. So maybe I have to do that like this. And that would still be faster. But it's not nice, like, I mean, I have to, it's like calling set state twice. I have to call set state and I have to set the run state. So this feels dirty, at least as dirty. I don't know. Let's keep this anyway. It feels the other one looked much cleaner what I had, but then we leave the function and then we have to re-enter it. That would be pretty fast, I think, but still. This is of course way faster. So we call initialize, and if we return from that, we set the state to the next state, and unfortunately you have to set the run state because that's what we use here. Alternatively, I could just call this function directly from here. But then, yeah, that's as much as a duplicate, I think, because I call it here for a run state, and then I call it here for that one. I don't know. If I really do not want to change run state, then I could, I guess, I could okay, I'm changing this back. I'm changing it back. Default. So now my break again is just return, because breaking out of the switch, there's nothing here. So breaking out of the switch is the same as returning from the function. And then instead of changing run state, I'm just going to call the multiplex directly. If I do not do this, it would also work. Same thing, but minusculely slower. And I don't like slow. I'd rather have code duplication than that it is slow if I have to choose. Now I could make the code look more clean to turn these two lines into a single function call. And then give it a name like continue in the base class. But let's not do that for now. Okay, so now I want to switch to the other one. And the base class, which is the seriously, this thing is all the time stuck. getting so sick of it. And the main problem here is what I'm running here is mPlayer, and then I give it a whole list of MP3s. And mPlayer is closing the audio output thing, so it's closing the jack client and then reopening a new jack client and then playing the next MP3. So it continuously closes the jack client and then reopens it. And that's what causes the problem. I think it's not, I mean, when I open it, so this client is created, and then yeah, another application sees that it appears, and then it connects it, makes these connections. But that takes a while. So it mPlayer already starts to play when while the output is not connected yet. That's what the error is. So a good solution would be not to close the jack client. Another solution would be to create the jack client and then wait 100 milliseconds instead of immediately starting to play. Either way, it's mPlayer's fault. So if anyone knows a good MP3 player that is not mPlayer, that uses jack as the output, let me know and I switch to that. Okay, that one is defined there. Let's go to here and then edit this again, and then also that one, but this one is in okay, so we start here, we call initialize, we set the state to CharacteristicRange initialized and run that. Then we come here and we run this state. So we directly called this function and we pass that directly as the argument. Therefore, this is being executed. This was commented out, but we just called initialize in the derived class. So this is now done. And indeed we have to continue with doing this. After calling this function, the task must go in a wait state, waiting for the do fill signal. And after it gets that signal, we want to continue not in filled, but in fill. But this is the base class. It doesn't know about that state. What I could do is just not set the state, set the state that I want to continue in before calling this. But then I'm running that without having set that thing as a state. That's kind of dirty, but it would work, I guess. So let's just delete this one. And then we go back again. And I'm going to set this one to nah, that's not going to work. Or is it? I want to call fill. Do I want to call fill from here as well? Okay, let's rename start to initialize anyway. Initialize. Okay, I'm going to call this one. I'm going to set the state to fill. I don't have it done. We don't have a fill actually here. But okay, we're gonna call fill anyway for now. Okay, let's see. Yeah, we must have the fill state, but we don't have a fill function. But okay, if we do not implement a virtual fill, then we just use the base class fill here, which is empty. So that's good to know. Cannot even find it. Nobody knows what that thing is. I changed a few things here. I have to find my states back. We don't have a start, we have an initialize. And we don't have a done, we have a fill. Initialize. So now again, we start here, we call initialize, and then I set the state in where I want to continue, namely fill, and then we execute initialized from the base class. Super dirty. Which is this thing, which does whatever it does, and then it waits for it to do fill or do terminate signals. Calls break, which causes us to leave this function, and therefore return here, which then we call break, and then we actually leave multiplex implementation. And then it waits for that signal, and when the signal is received, it will continue in wherever the state was set, so that's here. And then we do call fill, and then I guess we do the exact same thing. We do not set this because that's correct. I just call the base class field. And that means we run this, which checks if we must terminate. It should have done that before calling fill. Fill was here, right? So this is filled. And this is something else. Check terminate. It is a pretty dirty way of using my tasks, because I'm continuously calling states here without using set state. But on the other hand, I have the feeling that it works. I'm not really certain, I must say. Not certain at all. No, it's not. It's not good. Damn it. Not good. Nope. I think I need to use the same trick as the other one. Yeah, the continue state. Got the pass the ownership or whatever to the base class, and then at some point the base class might decide to continue running the derived class. So let's add a function called set continue state, I guess. Let's say I do set continue state. That's an our state. Our state is going to be fill. And the state that I want to run next is, yes, is this one. This one is not really necessary to set. But hey, if I do not set it, why not just set the run state then to it? And I remove this code duplication here. It is my experience that if you're unhappy with code and you just keep changing it and keep changing and keep changing it, and you can't get it right, there is always a way that once you arrive there, you immediately see that that's it. You know, this now we have it. That's what I was looking for. So as long as you have this nagging feeling that it doesn't look right, then it's probably not right. Now I must say I'm not super thrilled, but I'm on the other hand, this looks better than what we just had. So we begin here, we call initialize, and then you say if once we return I want to continue at that state. It means the only other state we have, and we definitely do not want to run initialize again, so it's kind of obvious. And of course we want to run now, or execute next, the base class initialized function, because we just called initialize. And now we simply do a break, so there's no code duplication in terms of calling multiplex. The only downside is that I'm running now this state without that I called set state before. Just the actual engine still thinks that this is the state. But as long as you don't return to the engine, that it doesn't matter, and that can't matter. So yeah, it should work, especially if we set the state again inside this function now for this state, and we will. Therefore, this works, guaranteed. Right. Now once we run this, you get yeah, exactly the same thing. Call fill, and then we run base class filled state. And the continue state is not changed, because if the base class wants to continue running this derived task, then it just re-enters there again. So I think this one is kind of finished and working, except that I do not have defined a set continue state, but that must be defined in the base class. I'm not adding enough comments. It's going to haunt me later on. Okay. So this is the base class. Initialize is being called. Means that we have to do that, then we wait for the do fill, and then after that we have to continue with characteristic range check terminate. So here we need a set state for that. If we are not terminated, then we must set the state to continued state. And then continue with that state in the derived class, which then calls fill. And after fill, will be called. We call that again, and then we have to continue again with check terminate. When we return from here, we got the do fill signal again. We want to continue here again. I think this works. I haven't seen our spam bots in a while. Do you think YouTube finally took action? ISO C++ forbids declaration of set continuous state with no type. Really? I deleted it. Yeah, that's what. Yeah, it got deleted. Okay. You gotta wonder if I should not turn this into a task as well. I mean, it is a task because it's derived from a task. But implement a multiplex thing here, define the direct base class, and then let this thing take care of the whole fill stuff. as in that we are not bothered by a field that doesn't even exist in the derived class anymore. Since that is clearly the right decision, I guess that's what I am going to do. So I'm going to have to edit this file, and let's copy stuff from the window, because that's my current example for derived tasks. Yep, let's copy it. We need all of this. Now the direct base class is already set to characteristic, so I can just hook in. I don't understand this remark. Oh, that is the remark for when you do implement it. I'm just going to delete all this. So now the direct base class of this one is the range, and the name is not uniform test whatever, but characteristic. And I guess that we do not want to have an initialize. Initialize is taken care of. I just want to do the fill thing. Or confusing. But I think that's the way it is, right? Don't understand it, but if you ask me, you need just a fill here. Yes, then I need to define these things, so I don't have a condition. I don't think, not yet anyway. But I do need this. Just make it protected. I don't even know what it must be. What was it here? Protected. Protected. protected it is. Don't need that. Just delete this. Don't need it yet at all. Yet or at all. We're gonna need a multiplex, and I guess that's it. It's the end of the class here. Just copying everything. Okay, so we do not have an initialize anymore. Let's rename these things. We do not have an initialize. So this thing is not doing anything, just calling, it's not calling fill, and then it continues as if it did. So then this state, we don't have this state because we are derived from characteristic, not from characteristic range. So instead of continuing here, we want to continue in with the characteristic fill of the base class. And then we don't have this state anymore. Hi Nikon, welcome back. I think it works now. Yep. And I just want to write stuff to file and then to have a quick look at I want to see colors. Let's run, let's go to, I don't know, initialized. Pipeline factory initialized. Pipeline factory initialized. Run. So begin here, call uniform buffers test pipeline characteristic initialize. Entering initialize. That's doing a whole lot of stuff. Now it's doing the partition stuff. It takes a very, very, very long time. And gets back here, does some more stuff. And then eventually we're done here. So signal characteristics initialized. Initialize just finished. And then we are going to do the following. Do what? Do fill, do terminate. There's a break missing. A break is missing. Okay, after adding that, I'll just run it again. I want to fix it immediately. I don't see it anymore. Set state. I don't see it anymore. Here it is. I'm just going to search for do fill thing afterwards. Quit TPS do fill TPS. Okay, it's return do fill. How is there a break missing? There's a return there. Oh, it's printing this without an or sign in between. Well, find that back. I don't know how to find that back. Wait. It's probably printing it. Task wait. Wait is here. Print conditions. That is the one then. Print conditions. Simply returns conditions, and then that is being printed by this friend, which has a print on. This is printing conditions. Otherwise you call print on, because that's on. Conditions. Yeah. What? Where's the thing you find in? not printing the prefix. Nee. Oh, BT. That's my mouse. Cool. Now it looks better with an or in between. So now we have this color. I guess that signal, yeah, that's the end of initialize. Therefore, we send a signal initialized. State is set to characteristic range check terminate. And then finally we call the wait, but the signal was already received, so it just continues. Need to run. No need to run. It's a different signal. Oh, I'm confused. Yeah, no, indeed. It's going to wait for the do fill signal. We didn't have that one yet. Next state is a pipeline factory characteristics initialized. And we are going to wait for the characteristics initialized signal. And that was the one that already was received. So then we continue immediately with initialized. And then the pipeline factory is going to do the multi-loop thing and send the signal do fill because it wants to call fill now, which then begins with checking if we are terminated. And because that's not the case, we continue with fill, which gives the signal filled. Next we want to continue with check terminate again, and then we call wait do fill again, and then we continue with filled, and then we wait for that, but the signal is already sent here. So we continue with state pipeline factory characteristics filled, and then we're not going to call fill again, so that's it, but we still have to be aborted, especially this one. It's waiting for do fill, and we're never going to do fill anymore, so it must be aborted at some point. No, we're not aborted. What happened again? Terminate, of course. So also waiting for terminate. So we're doing stuff, and then did I highlight the right one? I did not, I think. Oh, they have the same pointer, of course. I was looking for this task, but it is the same pointer because it's the base class. What you see here is just the base class pointer actually, but yeah, so I do have the right one. I think this is the other one. You have a second pipeline. Also doing fill stuff. Yeah, I don't know. Well, hopefully we get a terminate somewhere. Eventually. It should happen when the pipeline factory is done. Creating the pipeline factory. Creating the pipeline, I mean. Just waiting for a highlight. There's a highlight. There it is. Signal do terminate on that task. And then it calls CharacteristicRange check terminate, which now calls finish, which then calls finish implementation, the default finish implementation. We do the call back, which you don't have. We are killed. And then we still need to be deleted. So I need another highlight somewhere, or it is actually being deleted. Disappointing. I don't see it. Are we looking at a memory leak here, or was the thing not deleted? For example, if I take this one, do we see that one being deleted? It's also finish, call back, killed, erasing, stateful task, but that's because, yeah, see, there we actually see a destructor being called for that thing. But apparently only because we print something. I don't have a destructor, right? So we're not printing anything for that task. Maybe I should do that then. The most derived task, add a destructor just to print when we are being destructed. Yeah, maybe. It's just a test application, but how was that printed? Change content. Entering. Do you believe that I still missed something? Just look at it again. Unbelievable. Vulkan. Okay, it's printed on Vulkan. What did you say so? Vulkan. And now we printed this pointer. Actually, I think I just have to print this like that. RC says, did you already implement thread locking? I'm not sure what you mean, thread locking. You mean in mutex? Is that mutex is part of the standard? I did implement a lot of things related to threading. My task is one of them. An AI thread safe. Click, click, click. Nothing happens. Yeah. So maybe you mean something like this? Instead of a mutex, I usually use that. It has a readme. It kind of explains how that works. But the tasks are a very important part of it. So we'll look to the tasks. I want to go to home. Why is this image broken? I guess this applies thread safe by design. I'll read it out loud. So this is one of the many things that I wrote in the past 12 years. I'm using code till 20 years old, but I rewrote it so often, improved it so often that the first 10 years I just ignore now. So let's say before the Vulkan engine, I worked 10 years almost on just on fundamental utilities and libraries for C++ projects in general, of which this is one. An AI stateful task helps in many ways with writing a heavy multi-threaded program without running into all of the normal problems. Each task is an object with its own private members that it is manipulating. The core of a task is implemented in a single virtual function, multiplex implementation. Only one thread at a time will execute that function, so it is basically single threaded. No mutex locking is necessary for any of the private variables. Synchronization with other tasks is provided by the library in a fail-safe way. So by using that, I kind of do away with the need of for mutexes. I can create many tasks, allowing me to utilize parallel execution, but I don't need to use mutexes myself. The library takes care of it. But it is this is a whole different paradigm, if you pronounce it like that, which I invented myself. And if it already exists, or I think I'm definitely first, but it takes me so long to write it that maybe, I don't know, someone else also did it in the meantime. Coroutines come to mind. They they kind of are overlapping, I think. Though I never looked at it. What coroutines it is. Okay, here, for example, parent task could start a child task that will call signal on its parent once it is done. Now, this is describing what we have been looking at the whole day so far, or the whole afternoon. What I'm working on. The parent has to wait until the child has finished, and therefore calls wait immediately after starting the child task. That's exactly what we are doing now too. I'll point it out in a minute, in the code itself again. This normally leads to a race condition. Will the signal arrive before or after the parent calls wait? But here it doesn't matter. Both the signal and the wait are merely toggling a flag and are processed automatically once the parent returned to the library. And it has to be decided if the parent task needs to go to sleep, which it will only do when wait was called and signal wasn't. So in our case we continually call signal before wait, but the result is the same because that set a bit, that set a bit, then we'll return to the task engine and it says both bits are set. It's not that simple, but it's basically the idea, and therefore there is no race. And the task is run from an AI engine. We don't do that, by the way, but you can. Well, I do that in the Vulkan engine, but I use an AI engine to execute synchronous tasks, that are tasks that have to be executed in between frames. So it runs synchronous with the render loop. Those tasks are run by an AI engine which gets CPU by the render loop itself. So when a task is run from an AI engine, then it is executed from a known point in the main loop, in this case the render loop, for example, some other library. That means that the task runs at the moment that the library doesn't run. So again, there is no need for complex mutex locking. This is the preferred way to run tasks that have to interact with non-thread safe third-party libraries, aka Vulkan. That is, Vulkan supports multi-threading, definitely, but they leave everything to the coder. So you have to do all the logging yourself. And I really hate mutexes, because a mutex could mean that your thread has to go to sleep, which is a system call that takes 50 microseconds. And then again 50 microseconds to wake it up. And if you do that a lot, then you're losing a lot of time. So I don't want to do that. I do use mutexes, and they are very fast. Typical mutex takes nanoseconds, and I want 15 nanoseconds. Provided there is no contention. So it may not be locked, and you may not have other threads that access the same mutex in whatever way, same memory location of the involved atomics, within say 150 nanoseconds. So if you just do a lock and then do something and then immediately unlock, then normally it doesn't cost any time. While the 1 in a million time that it is executed concurrently, then things do not go wrong, because you use your lock. That's the right way to use mutexes. You should not use mutexes and keep them locked for a microsecond or 10 microseconds, or God forbid for a second. Anyway, feel free to use it under the GPL3 license that they release everything under. Or maybe I should release it again under a different license. I want people to use it. Otherwise I did everything for nothing. Yeah, a task runs by calling multiplex function on it. So the task does not get CPU anymore, means that the task engine stops calling the mutex function. So you can literally have 1 billion tasks that all not run, and they only take up memory. Absolutely nothing else, as long as they don't run. It's printing in the outputs as well, so here on there. So, yes, here it says no need to run, removing from thread pool. Then whatever it's doing then is causing it to not to get CPU anymore. So we can have a look at it. You can just grab this string and then see what it does. Oops, that's more internal. This is a macro, so if you run it, compile this in release mode or without debug, then the macro is empty. All of this is just gone. It's not there. But libcwd is very fast. I hardly ever feel the need to turn off debugging output. If I print to a file, and the only limiting factor is the speed at which the file can write to disk, if you ask me. I have a gigabyte of debug output, and then I have a gigabyte of debug output. Hardly slows things down. Okay, if keep looping, that means that we want to return to the top of this function, continue running this task. If we don't want to keep looping, and we certainly do not want to keep looping when the task has to stop. If need new run, that means that it is also still running, but we are not going to immediately do that. So this is also false. Else remove this task from any engine, causing the engine to remove us. So it sets the current handler to idle, and then that will cause the engine to remove this task. Normally it just runs over a bunch, I think a queue of tasks, and then it loads the handler, and then it executes it in that handler. So if it loads a handler and it sees that it is idle, then instead of running it, it removes it from the queue. But that happens the next time it would normally run. Oh no, I can't find it. I don't think I can find it back. It's a pretty complex piece of code, this. I think I already told it before on the stream, but like I said, people keep refreshing, so can tell it again, I guess. So I've been in Second Life for a long time, and LinLab, the guys that run it, they just ban left and right. Well, people put in a lot of money and a lot of time, and then suddenly you can lose your account. I mean, if you I kind of lived in Second Life, like hours and hours a day. Building things, had my own island, and the very idea that I could just lose everything, and of course, then you cannot even contact them, and if you contact them, they don't answer, you know, that kind of companies. That was so unacceptable. I could not work on my island and build beautiful things unless I had it on my hard disk. I want to own my own builds. How strange is that? It's like crypto. If you have crypto on exchanges, then it's not your crypto. You could suddenly lose it. If they remove your account, you just don't have anything. But that parallel people probably only understand when they are into crypto. So I started to write what I call a copy bot, but then a good one. I never released it to the public, so that is my ethics. But I wanted to have it for myself. And a copy bot is basically normally it is something that runs outside of the viewer. It connects to a server and then allows you to make copies, or maybe it is part of a viewer also too. You have to select objects, I guess. And it works by the fact that you must be able to draw what you see. So the only way to, well, at least the way that the Second Life viewer works is that you just download all the textures and you download all the 3D models, and then your GPU card draws it. So it is all known. One of the only things that is not known are the scripts, because the scripts inside objects, they run on the server, so you don't get to see them. But everything else can be copied, because you have to draw it. And then the opposite, rebuilding. Say you have copied an object and you want to rebuild it, which is then of course also immediately full permission and everything, because you build it yourself. That requires all kinds of things. Like first you have to rest the prims. All the building blocks must be put into in the virtual world. So maybe you need a few hundred. You have to all create them. You have to position them. You have to rotate them. You have to reshape them. You have to apply the textures. You have to link them. All kinds of things that have to happen, and in a certain order. And when something didn't happen yet because the server is slow, you give the command to the server, create this primitive, a cube, and it takes a while until the server did that, and only after it created it you can start to move and rotate it, not before. When you want to apply a texture, you first have to ask the server for the texture, which then is being downloaded, and only after it is being downloaded you can do something with it. So it exists of a lot of tasks that continuously have to wait for each other. And while I was writing this, I started to see a pattern in this code, and I turned the pattern into more common code. Let's say first I had a lot of code duplication, basically, of things that were doing the same thing. And then I turned that into, let's say, base classes. And then I saw the pattern became more and more clear. And eventually I thought, I'm just going to write a library for it. And that became then in the end AI stateful task. So then I redid my whole copybot viewer based on AI stateful task, and that revealed a lot of problems, like really difficult things that can happen. And yeah, I kind of got how it works internally, but what I still remember is that it is a way more complex than at first I would imagine. And that now it's magic, it just does its thing. And if you ever feel limited, if I'm using it and there is something I cannot do, then it probably has a good reason. So I'm unfortunately forgot more or less how it exactly works internally, but yeah, that then automatically also makes me a bit scared to deviate from the correct way with capitals to use it. RC, I've been coding C++ for the last 28 years, and I started coding 46 years ago when I was 12. I've been coding a lot, also as a kid and as a teenager. I slowed down a little bit with the coding while I was doing university because I did physics and I had to study, of course. But yeah, after my PhD, I became actually a programmer. That's when I started learning C++. So I must have already been, I was already 30. I'm now 58. But I had done a lot of C. So I had done a lot of coding in before that time, and also a lot in C. And then when I finally started learning C++, I was immediately sold. C++ is so much better. It supports exactly the way I code, the way I think, the way I was thinking back then. Oh, well then you must... How old are you now, if you may ask? I mean, when I was 9, I don't think there were computers yet. I was one of the very first computers that were made available to the public. It's the TRS-80, and when that was made a hype for companies, they had shops in the city that I lived, where they sold those things. Well, you can have a bright future in front of you as a programmer, but don't do it for your career, I would say. Just do what you like. You will learn more when you do things that you like. So if you like programming, you should do that. And yeah, I mean, if you really want to make it a career, then maybe you should concentrate a little bit on artificial intelligence, because that's definitely the direction it goes in. I think at your age, I remember things that just go way faster. I would not think of trying to get my CPU to draw from text. You have to download something and then type in text and then it draws that. It's open source. You can just download it. OpenAI. I think that especially at your age, you can do that because you just do it. That's your age. That's the beauty of your age, I must say. You just get an idea and then why not? So yeah, watch some YouTubes about AI, OpenAI, things that are free that you can just download and try out on your own GPU and start playing with that. I think that's a very good direction to teach yourself new stuff, considering what the future of programming is going to contain, to be about. Neural networks, stuff like that. If, say, in the next 10 years you would do nothing but the same as I'm doing right now, then you would suddenly be 24 and know nothing about neural networks. Well, that is the future. But I wouldn't feel bad if you do that, because you just like C++. It's all about the fun that you have with it. What do I think about CPP core guidelines? Never heard of it. So RC, are you using Linux as an operating system? Cool. Well, then at least you can use my code. What I write is Linux specific. But if you code from a command line like I'm doing, then there are certain things that you just really absolutely have to use. And beginning with installing that and getting it to work. It's a major production increasement. So this gives you control over the environment in a way that it depends on what directory you're in. So I'm now inside this directory that belongs to this project. And I have a gazillion environment variables that belong to this project. When I change that to, for example, I don't know, I always take make, I type configure when I want to configure my project, and I type make when I want to build it, right? So, which configure? This is my configure script. Which make? This is my make script. And you can make it as difficult as you want, although I have made it very general so that it is usable for many projects. So it's not like I have to copy this every project. I'm not sure. So if I do PE, I print my environment, and I think that make, it's not even defined in here. All the way in projects. Yeah, there's a, well, this is the, I don't know. I think this is the make that you just saw. So make and configure are in project. So they are written in a way that I can reuse them for every project, I guess. But they also have very specific things. So this environment is specific for the Linux project. Linux viewer project. Oh, it has its own make. So I did make changes for it, for this project. So I copied it and I made a lot of changes to it. I see. I wanted to make changes. But if I say I go to a different directory, you see history changed and the environment changed. So now go up, then I just have the history that I had there. History. So this is to do with music. And I go to royalty free music. No, that's not something else. I want to go to music then. Music. Royal. So I have a new history in this one, so I can just play the music, you know, the same thing that I'm doing in this window here. So I can never lose that. I just cd to this directory, and then I have my own history for the commands that I don't even have to make an alias for, because I cannot forget them, as long as I don't forget the directory where I used it. This directory is... sometimes I reboot from this directory, apparently. Yeah, well, I think that is very important to use. And then maybe you can have a look at my code, like the utilities that I have, that I wrote. So I have utils, just a collection of things that I use often in many projects. And split it up in util threading. Don't get too addicted to it, I guess, because it comes with a license, more or less, you know. So if you I don't know, within a hobby, you just do whatever you want. But if you get extremely addicted to it and you write all your code using my utilities, and then I don't know how it would influence a future career. If you suddenly have to unlearn it again or write it yourself, I don't really care. Actually, I don't really care. I mean, by the time you're an adult, you would start this for commercial stuff. My code, do whatever you want. I don't care. But as an already rich company like Google would start using this to make money, then I would care. I don't want it. I'm using Arch. If you are using Ubuntu, please stick with the Ubuntu, because Arch is extremely difficult to install, I think. The reason of Arch being so good is its how-to, and you need to be an expert. So maybe if you have a very good memory, like you have the feeling that if you read something, you just remember it and you keep remembering it, then maybe Arch is for you. You can just start reading. But I think that Arch kind of forces you to become a Linux expert, because you can only get things to work by reading all the details, understanding all the details and the technical things. So it's very time consuming, and you must be smart. I mean, if you just if you can't remember it or you cannot understand it, then all that time-consuming stuff is one, frustrating, and two, waste of your time. But if you have it in you to become a Linux expert, then Arch will force you to become a Linux expert. But again, time-consuming. Because in the end, you have to learn it all yourself. You have to do all the reading. So I have the feeling if you start to use Arch, then you might have to give up programming for a while. You know, maybe the next year, or just learning Linux. Huge learning curve. I did make a repository on how I installed Arch, which might be helpful for people that really want to install it. See if you can find that back. or you can just use the Arch how-to pages, of course. They should be excellent or whatever you want to do. Yeah, my Arch install. The description is this is a very personalized setup on how I installed Arch Linux in a reproducible way. I had so many problems installing it that I had to install it 100 times, every time tweaking a little bit. So I started to automate everything. And this then contains scripts and code and everything to reinstall my Arch from scratch. But it is very, very personalized. It's completely tuned to my hardware, of course, and other stuff like that. I mean, my partitions are called like this. I have an NVMe solid state hard disk of 1 terabyte. I think. Extract it, you get these scripts. Then I reformat the NVMe. Prints out what it does and then the command that I used. So at least you see all the commands that I use for my PC. But okay. I have a lot of partitions. Right. Well, I've not been using Arch that long, and I still found it hard. Maybe 4 years ago I installed Arch or so, and I could not get it done. I only got it done by extensive help from IRC, people on IRC, but well, I have the feeling they moved on a little bit. I don't see that much help anymore on the IRC Arch channel. Maybe I'm not paying attention. Yeah, the few very, very knowledgeable guys with a perfect memory, you knew everything, had seen everything, and were like 24/7 on IRC. So you just paste an error, of well, pasting is not allowed, but you just have a real error and you don't understand it, and then it's like getting help from one of the world's best system administrators. And they also saved me several times when my PC suddenly didn't want to boot anymore. So I had a second PC, and then with the second PC I go to IRC and say, help, I can't boot anymore. Happened to me several times. And then with their help, yeah, they know exactly what they're doing. They are much better than me. I'm not a system, not a Linux system administrator by any stretch. I'm just using it, so maybe I should not be using Arch either. I just wanted to see it for myself, how Arch is, one time. But yeah, RC probably left. We'll see you next time, I guess. Shall we go continue with turning on the lights here? How late is it anyway? Yeah, I should go eat. We turn on the lights. That run highlight is not what you want to see. Maybe I want to see running state. Okay, pipeline factory is still running here, but I want to see characteristic change, check, terminate, whatever. So let's look at this one and then see where it is terminated. Signal do terminate, blah, 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 killed, removing the thread pool, and now we should have a destructor somewhere. Also just added it. There it is. Entering uniform buffer tests, blah blah blah, destructor. Feels like a bit late, you know. Why would it be only destructed here? Okay, it's I think it is being destructed as part of destructing the pipeline factory, which makes sense. But I might as well kill it before that. Kind of depends on how long has this pipeline factory been finished. Yeah, this is the point where it is done. Let's finish. Might as well get rid of all the child tasks, keeping memory. Yeah, it feels like it's being kept alive too long, but there might be a reason for that. Anyway, we're sending the signal do terminate to it, and then it's not. It still has to be running for a while. The question is, who is keeping it alive? That's a really difficult question sometimes. Okay, so this is where the signal is being sent, so I might as well grab for terminate. This one. The finish implementation. So who's keeping my characteristics alive? Well, those are the characteristics, right? So that's this thing here, which contains all the characteristic ranges, which we definitely are not running anymore or doing anything with it, if you ask me. No, we don't not. This is the pipeline factory too. I just want to clear this thing. So we clear this vector, make it empty. Then we destruct all these boost intrusive pointers, and that should destroy the characteristic range. But not immediately. That will only happen after it finishes running. It decrement the reference count. It's more correct to say intrusive pointer. vector index. So intrusive pointer. I must say I'm kind of confused why the pipeline factory is not destroyed just as soon as it is done. So now I'm about to destroy or empty the vectors at the end of the pipeline factory, but what we really need, I guess, is just simply getting the pipeline factory destroyed, which then would destroy all the vectors and therefore destroy all the child tasks as well. That seems more logical. Why is my pipeline factory kept alive? And by who? Pipeline factory is a task, so it has a reference count that works with the boost intrusive pointer. It's exactly this thing here. So here is something that can keep it alive. Pipeline cache. All the pipeline factories are here. It's so hard to track. It feels to me like when the pipeline factory task is done, then it should be destroyed. But as you can see, it's kept alive all over the place. This one is doing that very explicitly, and that is our test application. No, I don't see any later access. I only see it being accessed where we start the whole thing. What happens if I delete this thing? It's not even assigned. Oh, it is here. I don't understand this. Oh no, they're back. Well, no immediate crashes. Maybe it works. Don't keep it alive, but I don't think at the same time that it destroyed it sooner now, or did it? Much better. Much better. So it was an artificial thing that kept it alive. Thank God then it still worked the way it was intended. So the pipeline cache was keeping the factory alive because we need to merge it. We need to merge pipeline caches. As soon as we're done with the pipeline cache, then and the pipeline cache is destroyed, then also the pipeline factory is destroyed, and then we see that also the move new pipelines is being destroyed. I could destroy this one before the merge happens, because maybe it happens. Pipeline cache factory finished. It wants me to eat. I'll just keep it like this. So now the initialize must be moved inside the multiplex implementation. Yeah, I guess this can really be deleted. Okay. Well, I guess I finished with moving it into a task. So now the initialize itself. Is simply task. Wait, not that one. Oh, it is. Yeah. Yeah. So now this is a task, meaning that I can interrupt it at an arbitrary point, as long as I do not have scopes with local variables. So this is just a cast. I could repeat it. And here we have a scope, but I guess that's only for this namespace. No, here's shader indexes. So say the vertex index, shader frag index are local variables here, and then if I want to say interrupt the task here, then I cannot re-enter it later at this point. Okay, adding a case and then some state here, because then these are not known. So if I ever need to do that, then I just have to make this a member variable of the class. And then it will work, but I'll wait with that until it is needed. And now it's pretty short, so those are the only possible local variables that I have to remove from the stack then. Right. Might even think about now moving this into a state. Instead of adding it to some queue which then later executed, I could just register myself for a signal or an event. I have support for that. And then this task basically waits until that event happens then, and then it continues running the state that does this. That would be more in line with using tasks. I think that's what I should do, yeah. Get rid of this lambda and make it the state of the task. Yeah, but first I'm going to make dinner and eat. So I'll be back later.